Tutorial 8, Question 1a. Integrate x squared dx. If we were to differentiate x squared, we would multiply by the exponent and then reduce the exponent by 1. So x squared would become 2x. Integration is the reverse of differentiation, so with integration we increase the exponent by 1 and divide by the new exponent. So the integral of x to the n dx becomes x to the n plus 1 divided by n plus 1. So in this case the integral of x squared becomes x cubed over 3 plus a constant of integration. Now differentiation is easy, integration is not. So every time you carry out an integration, as a sanity check, make sure you differentiate your answer to confirm that you get back to where you started from. So differentiating x cubed over 3 plus a constant, the constant will disappear on differentiation and the differential of x cubed over 3 becomes 3x squared over 3. 3x squared over 3. The 3's will cancel, leaving us with x squared. So that's okay. Part B, the integral of x to the fourth. This is similar to the previous one except the exponent is different, so this time we're going to get x to the 5 over 5 plus a constant. Again we're going to differentiate this just to check. So the differential of x to the 5 over 5 is going to become 5x to the 4 over 5 and the constant will disappear. The two 5's will cancel, giving us x to the fourth, so that's okay. Part 3, the integral of x to the minus 3. Now there's nothing in this statement here that says x can't be negative. So if we're going to do as we did before, we're going to increase the value of x to the minus 3 and then divide by the new value. So if we increase minus 3 we get minus 2. That's to say minus 3 plus 1 is equal to minus 2. So the integral of that is going to be x to the minus 2 over 2, and it's normal to put the negative sign on the numerator, not the denominator, so that would give us the answer minus x to the minus 2 over 2 plus a constant. As before, we'll differentiate this to make sure we get back to where we started from. So the differential of minus x to the minus 2 over 2 is going to be minus, we multiply by the power, so it's minus 2, and then we reduce the power, so that becomes minus 3. The minus signs cancel, the 2's will cancel, giving us x to the minus 3. So that's alright. Part 4, the integral of x to the minus 1. Now this is a special case because if we increase minus 1 by 1 we get 0, and if we were to divide by 0 we would get infinity. So that's not going to work. So this is the single exception to this rule. And this is one of our standard integrals, which is the integral of x to the minus 1, or the integral of 1 over x is equal to log x. Sanity check for this is we differentiate it. The differential of log x is x to the minus 1 or 1 over x, and the constant of integration of course will disappear. Part E, the integral of a to the 3x dx. This again is one of the standard integrals that's on the table, and the answer to this is given by a to the 3x over 3 log a plus a constant. As before, we'll differentiate this to make sure we get back to where we started from. Now there's a slight problem here, which is that we're trying to differentiate a to the 3x. We need a little trick. A to the 3x is the same as e to the natural log of a to the 3x, and we can reorganize that to say that that is equal to e to the 3x log a. Now the differential of e to the function of x is e to the function of x times the differential of the function, which means the differential of 3x log a is going to be 3 log a. The exponential remains the same. The 3 log a in the numerator will cancel with the 3 log a in the denominator, and now we've got e to the 3x log a, which is the same as e to the 3x log a here. We know from before is a to the 3x. So that checks out. And that's the end of question 1.